In November 1942, during Operation Torch in North Africa, American M1 Bazookas arrived without any trained operators to use them. General Dwight Eisenhower learned just before the landings that none of his troops had received proper instruction on how to handle this new weapon. Shortly after deployment, German forces managed to capture several intact bazookas from unprepared American units that abandoned their equipment during initial skirmishes. These captured weapons set off an extraordinary reverse engineering initiative for World War II. The seized M1 bazookas were a novelty in the context of German military strategy, as they represented a portable and highly effective anti-tank weapon requiring minimal manpower. German forces quickly transported these weapons back to Germany for detailed analysis at Kummersdorf testing grounds south of Berlin. Here, experts from the Wehrmacht began their first comprehensive examination of American rocket launcher technology. The insights gained would significantly impact German infantry tactics in the later stages of the war. The technical review highlighted both advantages and limitations. The M1 Bazooka fired a 60 mm rocket using battery-powered electrical ignition, with its shaped charge capable of penetrating around 75 to 100 mm of armor under optimal conditions. It weighed roughly 7 kg and could be operated by just one soldier. However, German engineers promptly identified several critical weaknesses that needed addressing. The primary concern was the battery-powered ignition system, which had proven unreliable in extremely cold weather based on their experiences on the Eastern Front. The wooden shoulder stock of the American bazooka housed compartments for 4 D-cell batteries, 2 in active use and 2 as spares. However, these batteries became unreliable due to moisture and extreme cold temperatures. Any German adaptation would necessitate a more dependable ignition system. Recognizing that the 60 mm warhead was ineffective against Soviet T-34 tanks with their sloped armor, German engineers concluded that it needed an upgrade. The Wehrmacht had access to 88 mm shaped charge warheads for the Rakethammer 43 Pupchen, a wheeled anti-tank rocket launcher that cost 730 Reich marks to manufacture. By adapting this ammunition for a shoulder-fired weapon, superior penetration could be achieved while leveraging existing production facilities. In March of 1943, at Kummersdorf, there was an important demonstration where captured American bazookas were fired alongside experimental German anti-tank weapons like the Effer Patron. This event convinced the observers that developing a German version was crucial. The captured weapons demonstrated the concept's viability, and German engineering would enhance its lethality. The development process proceeded with remarkable efficiency. Engineers substituted the battery ignition system with a magnetomechanism activated by a spring-loaded rod striking a generator to produce electrical current, eliminating cold weather issues while ensuring reliable ignition. The tube diameter was increased to 88 mm to accommodate existing Pupchen ammunition, offering nearly 50% more warhead weight than its American counterpart. One significant compromise emerged. The German rocket motor continued burning for about 2 meters after exiting the launch tube, unlike the American version which burned out inside the tube. This extended burn time increased range and velocity, but produced a substantial backblast that endangered operators. Early users found that the exhaust could cause severe burns and temporary blindness, leading to the weapon's nickname Ofenrohr, meaning stovepipe. By July 1, 1943, German documents officially designated this new weapon as the 8.8 cm Panzer Bazooka. The name was soon changed to Raketen Panzerbuchs 40B43 RPZB3, commonly shortened to RPZB43. Preparations for production were already underway at several factories throughout Germany, but mass manufacturing would commence only in September. The mobilization of the production infrastructure was executed with characteristic German efficiency. 6 main manufacturers secured contracts to produce this new weapon: Ensinger Union in Fedsheim, Hassag in Mosowitz, Gebruder Scheffler in Berlin, Jeckel in Freistadt, Kronprinz in Solingen, and Schreer in Fürth. Each facility was tasked with manufacturing specific components or complete weapons, with final assembly taking place at multiple locations to safeguard against Allied air raids disrupting the entire program. On September 8, 1943, a military report indicated that the weapon would soon be sent to frontline units for trials. By September 30th, the official manual for the Raketen Panzer Bazooka had been published. The first shipment of 1,500 weapons and 5,000 rockets reached combat units on October 5th. The transition from a captured American weapon to German mass production was completed in under 11 months. Production figures highlighted the extent of Germany's commitment to this weapon. Initial orders called for 382,000 units, but material shortages and bombing were to 289 151 RPZB-4 models by July 1944 when production ceased. An additional 25 700 improved RP-SB-541 models were produced between December 1944 and the end of the war. Manufacturing a Panzer Shrek required just 10 hours of labor at a cost of 70 rich marks, compared to the 5 730 rich marks needed for the smallest traditional anti-tank gun. This economic efficiency made mass production feasible even as Germany's wartime economy shrank. A single Panzer Shrek was less expensive than a military rifle but could destroy a 40-ton tank. However, the human cost of this production is one of the darkest chapters in the weapon's history. HASAG, the third largest user of forced labor in Nazi-occupied Europe, operated multiple production facilities that relied heavily on slave labor from concentration camps. By October 1943, more than 60,000 workers were employed by HASAG, with over half being forced laborers or prisoners of war. The company managed 16,581 prisoners across various subcamps by 1945. At HASAG's facilities in Poland, approximately 35,000 deaths occurred among the labor camps. Though incomplete records make an exact tally impossible, employees endured grueling 12-hour shifts amidst toxic chemicals, physical abuse, inadequate nutrition, and unsanitary conditions. The Schlubbenberger camp, which manufactured munitions such as Panzer Shrek components, housed between 2,000 and 5,000 female prisoners with an average survival rate of just 2 months. An explosion on October 12, 1944, resulted in the deaths of 96 prisoner laborers. The weapons began combat deployment in autumn 1943, initially in limited quantities as production increased. By January 1944, a total of 21-ton 41 units had been issued to front-line troops, although another 39,526 remained unserved due to distribution issues within the Wehrmacht system. German infantry units across all fronts clamored for these new weapons, recognizing their superior effectiveness against Allied tanks. Eastern Front forces were given priority access to Panzer Shrek supplies. Soviet tank commanders soon observed a shift in tactical scenarios. Where previously German infantry had relied on magnetic mines, anti-tank rifles, and bundled grenades, they now had access to weaponry capable of engaging tanks from distances between 150 and 200 meters. Each German defensive position could potentially house several rocket launcher teams. The weapon demonstrated its greatest strength in static defense scenarios. According to German tactical doctrine, Panzer Shrek teams were instructed to set up interlocking fields of fire from concealed positions. They dug staggered trenches no more than 115 meters apart to ensure that attacking armor faced rockets from multiple directions. Against moving targets, the effective range was approximately 100 meters. However, static targets could be engaged at greater distances. Technical performance data from tests conducted by German and Finnish forces highlighted the weapon's capabilities. The RPZB-432D2 rocket achieved penetration of up to 160 mm of armor at a 60-degree impact angle or up to 230 mm when hitting perpendicularly at 90 degrees. The rocket's velocity reached 110 meters per second compared to the American bazooka's 85 meters per second. Its warhead contained 700 grams of explosive, triple that of the American weapon. In February 1944, the addition of a blast shield produced the RPB-54 model, which became the standard production variant. This shield provided protection to operators from the rocket's backblast, despite adding an extra 1.75 kilograms, increasing its weight from 9.25 kg to 11 kg. Operators still needed protective gear like gloves and face masks due to the extended danger zone behind the weapon, ranging between 10 and 30 meters. Deployment on the Western Front sped up ahead of D-Day. German troops in Normandy were equipped with thousands of Panzerfausts to combat Allied landing craft and tanks near waterlines. These weapons demonstrated significant effectiveness in bocage terrain where short engagement ranges and ample cover favored their tactics. American tank crews, aware that they had created a weapon turned against them by the Germans, devised countermeasures such as additional armor plating and infantry shielding. The psychological toll often surpassed physical damage. Allied tank crews feared every potential hiding spot for Panzer Force teams, knowing a bright flash followed by smoke would signal an imminent threat. Reports indicated decreased crew efficiency in areas with high concentrations of these weapons. Even before the war's end, international distribution began. Finland purchased 180-54 launchers and 18 650 rockets for 200,000 rich marks, achieving notable successes against Soviet armor. Tests confirmed penetration of 100 mm of face hardened armor at a 30-degree angle. Hungarian forces received Panzerfaust for Operation Spring Awakening in March 1945, the final major German offensive. Allied intelligence closely tracked this weapon's impact, with a British report from January 1945 noting that German production over 18 months reached nearly 300,000 units, surpassing total Allied bazooka production. American ordnance experts acknowledged that the Germans had improved every flaw in the original bazooka design, creating an enhanced weapon from captured examples. The Americans then adopted these enhancements for later models, such as the M1 Bazooka introduced in October 1943, which featured magneto-ignition similar to the Panzerfaust, eliminating battery issues present in earlier versions. Additionally, the M20 Super Bazooka, developed late in the war, increased caliber to 3.5 inches, inspired by German advancements in warhead technology for enhanced penetration capabilities. Production data underscores the strategic significance of this weapon system to Germany's military strategy. By July 1944, when the RPB-54 ceased production, a total of 289-51 units had been manufactured. The peak monthly output reached 15,000 units early in 1944. Each unit required parts from 32 subcontractors, highlighting the intricate industrial process involved in mass production. An improved version, the RPZB-541, was introduced in December 1944 with a shortened barrel length of 135.7, an upgraded rocket propellant that minimized backblast, and refined sighting systems. Although orders for 48,000 units were placed, only 25,744 were actually delivered before Germany's surrender. Engineers also experimented with prototypes made from impregnated cardboard tubes to conserve steel, though none reached the production stage. Cost analysis explains why Germany prioritized the Panzer Shrek's manufacturing over other options. Each unit cost 70 Reichsmarks and required 10 hours of labor to produce. In contrast, a traditional anti-tank gun like the 3.7 cm Panzer 5036 cost 5730 marks and was ineffective against modern tanks. A single Tiger tank cost 300,000 Reichsmarks, whereas Germany could manufacture over 4,000 Panzer Shreks for that price. The production of ammunition paralleled the weapons manufacturing, with more than 2 million rockets produced. Predominantly the RPZB Gore 4322 model, known for its distinctive shape and fin stabilization. Each rocket weighed 3 kg and was packaged in wooden crates containing 2 units each. Special winter and summer variants were developed to address temperature effects on propellant performance. Transport frames enabled soldiers to carry 5 rockets at a time, though the weight and bulk limited their mobility. The weapon's impact extended beyond World War II. For instance, Belgian company Memar, which had produced Panzer Shreks under license, went on to develop the blinded-side RL-83 in the 1950s. Based on similar principles, the Swiss military introduced the 8.3 cm rocket-propelled grenade as RPG, keeping it in service until 1980 through various iterations. The fundamental idea of a large shape charge fired from a shoulder-mounted tube had a significant impact on anti-tank weaponry globally. Post-war evaluations by American ordnance experts recognized German accomplishments. In his 1946 report, Colonel C.T. Richards highlighted the Panzer Shrek program as one of history's most successful instances of reverse engineering, achieving mass production in less than 7 months after initial blueprint acquisition. The Germans transformed a hastily developed U.S. weapon into an advanced system that outperformed its predecessor across all metrics. Soviet forces seized thousands of Panzer Shreks during their advance through Germany. Red Army assessments concluded that these weapons were superior to the American bazookas received via Lend-Lease, which they initially dismissed as insufficiently powerful and only obtained 3,000 units with limited ammunition. The German model, equipped with a larger warhead offering greater penetration, better aligned with Soviet tactical needs. The last recorded combat use of World War II-era Panzer Shreks occurred during the Arab-Israeli conflict in 1948 when Syrian forces utilized captured German weapons. These weapons journeyed from German factories through various conflicts, showcasing the durability of their basic design. Some examples remained in Third World arsenals into the 1960s despite the availability of more advanced anti-tank systems. Technical documentation survived in remarkable detail. The September 30, 1943 Wehrmacht manual offered comprehensive guidance on operation, maintenance, and tactics. American intelligence translated captured manuals with a detailed October 7, 1944 report outlining firing procedures, aiming techniques, and safety requirements. These documents underscore the thoroughness of German training programs amid wartime constraints. Safety statistics highlight the weapon's hazards. German records show numerous operator casualties from backblast injuries, premature detonations, and enemy return fire drawn to the weapon's distinctive launch signature. The 10 to 30 meter backblast zone behind the weapon required careful positioning to prevent injury to friendly troops. Urban combat posed particular risks due to potential backblast, reflection off walls, endangering operators. A comparative study with contemporary anti-tank weapons highlights the Panzer Shrek's place in the evolution of such armaments. The British Pat weapon, which utilized a spring-launched Spigot mortar mechanism, had a longer range but offered less penetration power compared to its counterparts. Conversely, the American bazooka was more portable yet inferior in terms of armor penetration capabilities. The German Panzer fast provided ease of use and lower costs, though it could only be used once. In contrast, the Panzer Shrek managed to strike a balance by offering both reusability and considerable striking power. Throughout the course of World War II, there were notable fluctuations in manufacturing quality. Early models produced in 1943 exhibited superior craftsmanship with precision machined parts. However, as the war progressed into late 1944, production methods became more streamlined but used inferior materials, resulting in a decrease in overall quality, although the weapons still maintained adequate functionality. Captured Panzer Shreks demonstrated a noticeable decline in workmanship and tolerances over time, reflecting Germany's deteriorating industrial capacity. The weapon system had a comprehensive infrastructure that included training centers, ammunition storage facilities, repair shops, and distribution networks. Training schools for the Panzer Shrek were set up at various locations, churning out thousands of operators each month. Specialized maintenance units were stationed at division level to keep the weapons operational. This extensive logistical support was comparable to traditional artillery systems, underscoring the weapon's perceived importance. Environmental factors influenced its effectiveness in combat scenarios. The Panzer Shrek performed poorly in extremely cold conditions due to inconsistent propellant ignition, faced issues with sand contamination in desert environments, and experienced electrical malfunctions during rainy or wet weather. Despite these challenges, the basic design demonstrated remarkable durability, functioning adequately across a range of combat settings from Arctic Finland to Mediterranean Italy. Allied forces developed countermeasures throughout the war by reinforcing tanks with extra armor plates, suspending sandbags for additional protection, and installing wire mesh screens to thwart shape charge attacks. The infantry employed bold reconnaissance strategies, moving ahead of tanks to neutralize the threat posed by Panzer Shrek teams, artillery, and mortars aimed at suspected firing positions. Despite these efforts, the Panzer Shrek continued to pose a significant danger until the end of the war. German tactical advancements enhanced the weapon's potency. Panzer Shrek crews identified specific vehicle weak points such as vision blocks, engine compartments, and track assemblies for targeted attacks. Multiple teams collaborated to overwhelm tank defenses. Urban combat techniques were refined to exploit the weapon's capabilities while reducing exposure to counter-fire. These tactics had a lasting impact on post-war anti-tank doctrine globally. Production quality control records from various facilities still exist today. Randomly selected weapons tested in 1943 showed that about 95% met specifications, dropping to around 80% by the end of 1944. The main issues were related to ignition systems and tube durability. Despite these quality concerns, high production levels ensured a steady supply for combat units. Beyond direct manufacturing costs, Germany redirected considerable industrial resources towards Panzer Shrek production, including steel, electrical components, and chemicals used in propellants and explosives. This shift consumed materials that could have been allocated to other weapon systems. However, the cost-effectiveness of the Panzer Shrek compared favorably with traditional anti-tank guns, justifying its allocation of resources. From a German standpoint, training programs evolved based on combat experiences. Early instruction focused on accuracy and safety, but later stages incorporated practical guidance from battle-hardened veterans regarding tactics, concealment, and survival skills. The Wehrmacht produced extensive training materials specifically for Panzer Shrek operators, including pamphlets and tactical guides. These documents captured by Allied intelligence offer valuable insights into the development of German anti-tank doctrine. As production grew, supply chain intricacies became more complex. The weapon necessitated specialized parts from various suppliers, such as electrical contacts, optical sights, steel tubing, and wooden components. Rocket manufacturing required dedicated facilities for warhead fabrication, propellant blending, and final assembly. Any disruption in the process could paralyze the entire operation, making it susceptible to strategic attacks. The Panzer Shrek initiative exemplifies rapid military adaptation amid intense pressure. From seizing American bazookas in November 1942 to achieving mass production by September 1943, Germany transformed an alien concept into a domestic capability. This was accomplished through practical engineering that leveraged existing resources rather than inventing new technologies from scratch. Despite the multi-front war, Germany managed to produce nearly 300,000 Panzer Shreks, showcasing remarkable industrial tenacity. The weapon resulted from thorough reverse engineering that pinpointed and rectified original design flaws. German engineers did not merely replicate the bazooka, they developed a significantly enhanced system surpassing the prototype in all measurable performance metrics. Beyond its technical accomplishments, the Panzer Shrek signifies successful technology transfer under combat circumstances, rapid industrial mobilization despite resource limitations, and effective military adaptation to enemy advancements. The program demonstrated that captured enemy technologies could swiftly be transformed into mass-produced weapons with battlefield impact. Contemporary military historians analyze the Panzer Shrek as a case study in efficient reverse engineering, swift product development during wartime, and industrial readiness. The timeframe from capture to large-scale production is still remarkable even by modern benchmarks. Few weapon programs have equaled this pace from concept to deployment, especially starting with captured equipment. The entire narrative encapsulates technical innovation, industrial achievement, and human tragedy. While German engineering merits recognition for rapid development and efficient mass production, the extensive use of slave labor must be acknowledged. Tens of thousands lost their lives manufacturing weapons that prolonged a futile conflict. The history of the Panzer Shrek is marked by both significant technical accomplishments and the systematic use of forced labor. Ultimately, it became the most effective reverse engineering initiative in history, converting captured American bazookas into nearly 300,000 enhanced German weapons within a single year. This program showed that military innovations could be swiftly replicated, improved upon, and mass-produced at an unprecedented pace. From its inception during Operation Torch to the final production run in April 1945, the Panzer Shrek exemplified the ingenuity and industrial capacity of Germany in response to urgent wartime requirements.